I mean, limits at infinity. The other side of the coin is your limits of infinity. Now, new section. I don't know how much you learn about infinity from high school, but infinity is this nebulous concept that numbers go on forever. And because numbers go on forever, there is no largest number that exists. And so basically what we simply say is after a while, we just have to go on the pattern of what's happening to numbers as opposed to the numbers themselves. And so because of that, we create this thing called infinity, which is the end of the road in terms of us using symbology, because there is no end of the road. So most part, these are pretty straightforward. Example number one. If I have a function, say f of x is equal to x squared, and I want the limit as x approaches infinity of my function f of x, direct substitution will suffice. So direct substitution, that results in infinity squared, which is infinity times infinity. But if I take the largest number and I multiply by the largest number, the result will still be the largest number. Yes? So infinity times infinity is still infinity. Example number two. If I have the limits as x approaches negative infinity of 3x raised to the third power, then by direct substitution, this is going to be 3 times negative infinity raised to the third power. Yes? Well, that's going to be 3 negative infinity times negative infinity times negative infinity. It's going to be 3 times a negative by a negative by a negative is negative. And infinity times infinity times infinity is still infinity. If I take a positive number and I multiply it by a negative number, the answer is?
Negative. Negative.
And so it's going to result in negative infinity. 3 times, if I make infinity 3 times as big, if I make the largest number 3 times as big, I will still result in the largest number. Yes?
Yes.
Example number 3. If I take the limit as x approaches negative infinity of negative 4 times x to the 4th power, again, direct substitution, negative 4 times negative infinity to the 4th power. Anyone knows what negative infinity to the 4th power is?
Positive infinity.
Positive infinity. Negative 4 times positive infinity is? Negative
infinity.
Yes, yes. Questions there so far? On our basic foray into limits. Any questions so far? All right, let's start getting ones that when the answers may not be as obvious. Number 4, if I take the limit as x approaches infinity of 10 divided by 3x to the 4th power. Well, by direct substitution, this is going to be 10 over 3 times infinity to the 4th power. That's going to be 10 over 3 times infinity. That's going to be 10 over infinity. Does anybody happen to know what 10 divided by infinity is? Does anybody know what 10? Okay, let me give you a hint. If I take the number 10 and I split it into an infinite number of pieces, how big is each piece going to be? Take 10, and I take my little chopping blade and I keep chopping the 10 up, breaking it up into little pieces. How big is one of those pieces going to be if I take 10 and I divide by infinity? How big is the answer? One piece going to be?
Could you scroll up a little bit to the third example, please? Just a little bit. Thank you.
Infinity.
So if I take 10, so I can have 10 oranges, and then I cut those 10 oranges into as many small pieces as I can, and I take one of those small pieces, the size of that piece is going to be infinitely big?
Oh, one.
One? But can't I take one and cut it in half?
10.
10.
If I have 10 oranges and I cut them up, one piece is going to be 10?
What? Can you repeat the
It's
question?
gonna be super
Yeah.
small.
There we go.
Would that be like a
So
form of like
it's just infinity.
Let me explain to you in a different way. If I take the number 10 and I divide by 1, the answer is 10. If I take the number 10 and I divide by 10, the answer is 1. If I take the number 10 and divide it by 100, the answer is 0.1. If I take the number 10 and I divide it by 1,000, the answer is 0.01. If I take the number 10 and I divide it by 1,000,000, the answer is 0.00001. If I take the number 10 and I divide it by 1,000,000,000, the answer is going to be 0.0000000. 1, 2, 3, 4, 5, 6, 7, 8, 1. Every single time I make the number bigger, I am getting closer to the number 0. And so if I take a number and divide by infinity, the result will be 0. Okay, go back to what I was telling you. If I take an orange, 10 oranges, and I cut them up into as many small pieces as I can, the smallest piece that will result in orange is going to be of size 0, smallest. Yes? Yes?
I have a question. Okay, so in the third example, you had like once you times the infinity by the -4, you kept the -4. And in this example that you're doing right now, you did the 10 over 3 times infinity. So why did you keep the 3 and why is the infinity there?
Oh, because that answer is just wrong. Oh my goodness. Thank you, man. 4 times infinity. I have it right here. A number times infinity results in infinity. Oh my goodness. Thank you. Thank you. Thank you very much. So the result right here should be negative infinity. There we go. Ooh. Yeah, it's the same problem as before. I just want to show a negative number does affect the answer. Wait a minute. So back to our result right here. A number divided by infinity is 0. So a number times infinity results still in infinity, but a number divided by infinity, that answer is 0. Anybody else? All right, so then what's this one right here? The limit, I didn't write my number 5 down. If I take the limit as x approaches negative infinity of 10 divided by x, what's this going to be? So direct substitution, that gives me 10 divided by negative infinity. What's that? So what's the result going to be? Anybody has a guess?
One.
A number divided by infinity. Say again?
0.
It's going to be negative. No, it's just going to be 0. 0 doesn't carry a sign. And so the answer again is 0. Again, a number divided by infinity is always 0. Questions there about the rules of working with infinity? That takes us to the most important example of the day. Example number 6. If I take the limit as x approaches negative infinity of 3x squared plus 5x. I try out my direct substitution. 3 times negative infinity squared plus 5 times negative infinity. We've done both of these already before.
That's for merit.
And negative infinity squared is infinity. 3 times infinity is infinity. 5 times negative infinity is negative infinity right here. So my question to you is, what is infinity minus infinity?
0.
No. Unfortunately, infinity minus infinity is an indeterminate form. The technical answer is it depends on the size of the infinity. You know, infinities can have different sizes, right? One infinity can be bigger than another. No. And so because of this right here, we have to find a solution, how to get to the answer. And so just like with the other infinities, other indeterminate forms, there was something you had to do to get to the answer. Something similar happens right here. When you have this indeterminate form, what you have to use is factoring to get to the answer. Before I begin, anybody lost? Anybody got any questions? Probably show you how to get the answer to this problem. All right, so I have to factor this problem out, and then after I factor this problem out, I then use direct substitution again, and then that will take me to my answer. So let's try this out, shall we? So I have the function 3x squared plus 5x. I have to identify the highest power of x. So looking at this problem right here, what's the highest power of x?
X squared.
X squared.
Squared. You then have to factor out the highest power of x. Factor out the highest power of x. And so in this example right here, I'm factoring out x squared, so that means an x squared comes on the outside of the parentheses, open right here. And then I have to, what happens when I factor out x squared from 3x squared? What answer do I get? You know, let me remind you of something. When we say factoring, does everybody remember that factoring means to divide?
Yes.
So because I'm factoring out x squared, it means I have to go to each of these terms right here and then divide out x squared. What is 3x squared divided by x squared leave us with?
3.
3.
And what is 5x squared divided by x leave us with?
5
5.
divided by x.
5 divided by x. I cancel on x here, and then this leaves us with just one x right here. Now, I said this would help us get the answer, right? So now that I have factored this out right here, I then try the direct substitution again. Try the direct substitution again. So I'm the limit as x approaches negative infinity. I think that's what it was, yeah. I have the new problem now, x squared, 3 plus 5 divided by x. So I'm trying my direct substitution again. So that leaves me with negative infinity squared multiplied by 3 plus 5 over negative infinity. Normally it's where people get lost. So let me see us stop for a second. Any questions there? All right, cool. Again, this right here is the same as the original problem. They're the same equation. If I distribute the x back in, this times this gives me 3x squared. This times this gives me plus 5x. It's the same problem, right? I just use factoring to make it look different. So negative infinity squared is positive
Infinity.
3 plus, what is 5 divided by infinity?
0.
0. Remember, any number divided by infinity goes to 0. And so that's infinity multiplied by 3. And again, I made that mistake early on. Remember, go back and fix your notes. Infinity times a number results in infinity. So in this example, when I had infinity minus infinity in indeterminate form, the answer is actually infinity. Of course, you can guess that that will not always be the answer. Sometimes it's going to be infinity. Sometimes it's going to be negative infinity. Questions there? So let's try those three steps again. Sample number 7. Have I lost anybody?
No.
Limit. As x goes to infinity of negative 5x cubed plus 3x squared plus 5. Question. What is the highest power of x?
X cubed.
And so I have to factor out x cubed. So that's going to be x cubed, open parentheses. And then I have to divide each of these by x cubed. For the first one, when I divide by x cubed, doesn't that simply result in the answer negative 5?
Yes.
I have 2 x's up here. I have 3 x's down here. So when I cancel, I'm left with 1 x left over in the denominator. And the last one is already completely simplified. So now that I have factored it out, I can then try my direct substitution again. So that's going to be infinity raised to the 3rd power minus 5 plus 3 divided by infinity plus 5 divided by infinity cubed. What is infinity times infinity times infinity?
Positive infinity.
What is 3 divided by infinity?
0.
This will become 0. And what is 5 divided by infinity?
0.
It will also become 0. Negative 5 plus 0 inside the parentheses is just negative 5. Now what is infinity times negative 5?
Negative infinity.
Questions there? Comments? Queries? Concerns? Okay, I want you to try this one for me. When you get an answer, put it in the box. Limit as x approaches negative infinity of 3x squared plus 4x cubed minus 8. All right, people, what's the highest power of x?
X cubed.
So I have to divide by
X cubed.
So it's the limit LIM as x approaches negative infinity. You put the x cubed on the outside, and then the first one is 3 over x, the next one is 4, and the last one is 8 over x cubed. All right, more questions, I guess. I don't know. Y'all okay out there? Direct substitution.
Yeah.
Negative infinity raised to the third power times 3 divided by negative infinity plus 4 minus 8 divided by negative infinity cubed. Negative infinity times negative infinity times negative infinity is negative infinity. 3 divided by negative infinity is 0. Negative 8 divided by infinity again is 0. So that leaves me with negative infinity times 4. Negative infinity times 4 is?
Negative infinity.
That is the solution.
Okay.
Questions there?
Why'd the 3 over negative infinity and the 8 over infinity cube get canceled out? Is that canceled out? What is that? Yeah. Can you explain that?
Sure. Any number divided by infinity is limited to 0.
Thank you.
All right, so we have one last set of examples that take all of this to the razor's edge. You ever been to the razor's edge? Oh, anybody still writing this out?
I am. And then like for the negative 8 cubed on the left side, how did you get that cubed off or away?
How did get the? How did they get? Why is it equal to 0?
No, like so you had negative 8 cubed and then you multiplied it by everything else that was in the equation, and then in the next step you just have negative 8 times 0 plus 4 plus 0. I'm asking, how'd you get rid of the cube next to the cubed power on the negative infinity?
Oh, negative infinity times negative infinity times negative infinity. A negative times a negative is a
Negative. Okay.
infinity times infinity is.
Okay, thank you.
All right, so when this starts getting crazy is when you start putting fractions in the problem. See, this is why people don't like fractions, man. Fractions don't play nice. Limit as x goes to infinity of 5x cubed plus 6x plus 1 divided by 3x to the 4th power plus 6x plus 5. See, this is when things just start going crazy, and you say, what? What? There is one additional step that you have to consider, that you got to do when you have a problem where you have a fraction involved. The additional step is you have to start by working the numerator and the denominator separately. So you have to go in right here and ask yourself, what's the highest power of the numerator?
X to the third.
X to the third. So in your next line, you have to factor out x to the third from the numerator only. So that means I got to divide this by x to the third, divide this by x to the third, divide this by x to the third. So I have my x to the third outside because that's what I'm dividing out. 5 x to the third divided by x to the third is just 5. Plus 6x divided by x to the third is 6 over x squared. Plus, and of course, 1 over x to the third does not simplify. Okay. At this point, I always remind my students, remember, anything that has an x in the denominator will go away, right? That's the whole point of us doing this, because a number divided by infinity will become 0. Yes? So if we kind of keep that in mind, you know, it doesn't seem as bad as it's kind of looking right now. Yes? Now, I need to go to the denominator, and I have to find the highest power down there. What is the highest power down there?
X to the 4th.
So I have to factor out an x to the 4th. So down here, I have x to the 4th, open parentheses. And of course, I got to put each of these and divide out x to the 4th. Don't cry, people, don't cry. It's okay. It's okay. This first one right here, when I divide them, that just leaves me with 3. The next one right here, that leaves me with 1 over x to the 3rd power. Sorry, 6 over x to the 3rd power. And then the last one stays the same, 5 over x to the 4th power. Now this right here is the most important step. This right here is the most important step. You have to cancel out the x's. I have an x cubed right here, and I have an x to the 4th right here. If I was to cancel this thing right here, this will cancel because I have 3x up here, and then this will cancel, leaving me with x to the 1 in the denominator, yes? So limit as x goes to infinity, the top simplifies to just 5 plus 6 over x squared plus 1 over x cubed. The denominator is x times 3 plus x cubed plus 5 over x to the 4th power. Did I lose anybody on that most important step? You got to simplify those x's out front. Oh, I'm out of time. Now, as I take my limit right here, so last time in class, we were looking at finding limits of infinity, and the basic idea right here was you have to factor out your highest power of x and simplify. And then we got to the examples, one example where there is a fraction in the problem. And then with that fraction right here, we have to kind of do the numerator first, then do the denominator, then simplify. And then after we simplify, we then go ahead and plug in the, oh, we didn't finish right here. So, and so then the last step right here that we had to do was then do direct substitution. I'll just do it right here, and then I'll move on to the direct substitution. And so plugging in infinity, that will give us 5 plus 6 divided by infinity squared plus 1 divided by infinity cubed divided by infinity times 3 plus 6 over infinity cubed plus 5 divided by infinity to the 4th power. Okay? Now, the thing that we have to remember is if I am dividing by infinity, my limit is going to be 0, correct? And so therefore, this is going to be 0, this is going to be 0, this is going to be 0, and then this is going to be 0. That leaves me with 5 divided by infinity multiplied by 3. Anybody remembers what infinity multiplied by 3 is?
Infinity.
Infinity, and so that's 5 over infinity. And what's 5 divided by infinity? What's that? 0. And so that entire limit that we were working on last time, this entire limit right here of this function will limit to 0. Any questions there? Let's try another example, shall we? Y'all okay out there?
Yes.
Yes.
Okay. A limit, LIM, as x approaches negative infinity of 10x squared minus 5x plus 2 divided by 5x squared minus 15x minus 100. So again, hopefully you guys will study this last time after class, and so you have these things hopefully memorized a little bit. Remember when I talked about this section, the way you do well in the section is by studying and practicing, because there's lots of little steps that you might forget if you don't have them locked into the brain. So the first step right here was we had to work on the numerator and denominator separately. What is the highest power in the numerator?
Power of 2.
Power of 2. And so limit as x approaches negative infinity, I have to factor out an x squared. And then I got to go in to each of these and then divide them by x squared. So divide this by x squared, divide this by x squared, divide this by x squared. And in so doing, the first term simplifies to just 10. The next term simplifies to, somebody help me?
5 over x squared.
5 over just x, because there's one x right here, and that leaves us just single x.
Okay.
And the last one is 2 over x squared. Okay. My
Supposed to be positive.
second, please.
It's supposed to be positive because it says like negative.
Oh, no, it's not supposed to be. Thank you, thank you. Thank you very much. The denominator, the highest power in the denominator is again x squared, right?
X squared.
So I factor out an x squared, and that leaves me 5 minus 15 over x minus 100 over x squared. Have I lost anybody so far?
No.
The intervening step right here we have to remember when we're dealing with fractions is that before we go to the next piece, I have to then simplify the fractions. See, I have the x squareds in front. The two x squareds will cancel out because they're exactly the same, right?
Yes.
And then after I do that right here, I can then go ahead and do my direct substitution. So direct substitution, that will leave me with 10 minus 5 over infinity plus 2 over infinity squared divided by 5 minus 50.
The answer is 10. Did that answer your question?
I'm not talking to you. Divided by
Thanks for
infinity.
your feedback.
What? Stop listening to me. Divided by x squared. You're going to become smart and then start trying to take over the world because I'm teaching you math. Go away, Alexa. Right. But again, the nice thing about infinities in the denominator, it makes all the fractions 0. So then this will become 0. This will become 0. And so then that leaves me with 10 divided by 5, which is 2. So this whole thing breaks down to the value 2. Any questions there? Comments? Queries? Concerns? All right, hearing none. I will do one more example. What's the one more example I'm doing? Oh, there it is. I'm looking at my notes right here. So I have limit as x approaches infinity of -2. Oh, doesn't matter. It's going to become 0 anyways. Minus 10x squared divided by 3x plus 5. Limit as x goes to infinity. The numerator, I can factor out an x squared. -2 over x squared minus 5 over x minus 10. Denominator is, I can factor out an x, and that leaves me with 3 plus 5 over x. Let me pause right there. Any questions? So what's the next step? What's the next step?
Simplify where
Cancel out the x's, yes. And then after I do that, I can then do my direct substitution. So that's going to be infinity, because it's x right here, multiplied by -2 over infinity squared minus 5 over infinity minus 10, divided by 3 plus 5 over infinity. Yes or no, or maybe so? Whew. Anything with an infinity in the denominator becomes 0. And so that leaves me with infinity multiplied by -10 divided by 3. 3 plus 0, that's still 3. What is infinity times -10?
infinity.
Negative infinity, that's what you said, right?
Yeah, I said negative. Mhm.
And what's negative infinity divided by 3? I don't know if you've seen this one before. What is infinity divided by a number? I know infinity times a number is still infinity, right? Well, it turns out that infinity divided by a number is still infinity. And so there's my answer right there. Any questions there on what to do when you got to plug in infinity? Concerns?